What is binary number system? Let us explore and learn. The objective here is to introduce to you the binary number system, which is base 2, compare it with the decimal number system, which is base 10, which you are familiar with, and then some basic questions: how computers use binary and why real world applications of binary numbers matter. I'm Anil Kumar. Welcome to my YouTube channel, a platform where both of us learn. Keep sharing and keep learning. So let's begin with the basic thing, which is: have you ever wondered how computers understand numbers? It all comes down to just zeros and ones. Welcome to our deep dive into the binary number system, the foundation of modern computing. Let's explore how zeros and one can make all the numbers. Now, in our daily lives, we use decimal number system, which is base 10, which has 10 digits 0 to 9. But computers think differently. They use binary system base 2 with just 2 digits. Well, that brings us to a very important question: that how with 2 digits we make up all the numbers. So let's first look into the base 10. When we say 0 to 9, we have 10 numbers, right? The numbers are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So these 9 digits make 10 numbers, base 10, right? And now any number which you write, for example, if you write 123, right? So it means 100, right? So it means 1 times 10 to the power of 2 plus 2 times 10 to the power of 1 plus 3 times 10 to the power of 0. So we get our number, anything to the power of 0 is 1. So we get 223. Correct. So that is how we read our basic base 10 decimal system numbers, right? Similarly, in binary system, we just have two numbers which are 0 and 1, right? So these are the two digits which we work with. Now, how does it make sense basically? In computers which are run by electricity, you can switch on or switch it off, correct? So a number is a bit, a digit, right? That digit could be on or off. So we'll, in our illustration, use green color for on and red for off, right? And in following videos, we'll see how this nomenclature will be used in very interesting ways. So the basic here is to understand that just if the switch is on, we get a number 1. If not, we get a number 0. But it is the place value which makes all the difference. Do you see that? So in your decimal number system also, 1, 2, and 3, they are occupying different place values. And that makes all the difference. Similarly, I could write a number which could be, for example, 101. Now, if my base is not 10, but it is 2, then this will be times what? This will be times 2 to the power of 0, just as we did 10 to the power of 0. And this will be times 2 to the power of 1, and that will be times 2 to the power of 2. You get the whole idea. Now, multiplying with zeros and ones is so easy, right? So, you easily get your number when you multiply anything with 1, you get the same number, right? So you can say that the equivalent number here is that when you do this multiplication, you get just number 1, right? When you do this multiplication, which is 0, right? So you add 0 to it. And when you do this, 2 to the power of 2 means 4 times 1 is 4, right? So you add 4, and the number which you get in this case is equal to 5. Makes sense. So you see how easily using just these two digits, 0 and 1, we can actually make all the numbers. And this computation is done extremely fast by the computers. Even with us, when we go for mental math, many times the strategy of using zeros and ones for fast calculation is very, very effective, which you are going to see in our playlist. And that's why we are introducing this topic. It is a very important chapter in my upcoming book where we are going to teach you how to do fast calculations. So, working like computers is what we are achieving here. Makes sense, right? So, let's move forward. Not much details now, but we'll definitely get into lot more details soon, right? So, of course, the question which always comes to your mind is why binary, right? Computers work on electrical signals, as I said. So, one means on, that switches on, and off is the state when it is zero for them. All data, whether it is text, images, sounds, or videos, is stored using binary codes in computers, right? Now, without binary numbers, we won't have modern technology. Remember that part, right? From smartphones to self driving cars, everything runs on zeros and ones. Perfect. And you've seen how effective zeros and ones are. Now, here is an illustration where we are going to summarize what I just said, right? So, we'll compare binary versus decimal, right? So, some very simple thing is binary, we say base 2. Base 2 because there are two numbers, and these numbers are 0 and 1, less than 2. Get the idea. 2 is not the number of binary 0 and 1. Similarly, base 10 means we are talking about digits 0 to 9. 0 to 9 means 10 digits. 1 to 9 are 9, and 0 is the 10th digit, correct? So, so we have 0 to 9 digits for base 10 decimal system, and 0 and 1, just two digits for binary system, right? Key is place value. Where you put the digit makes all the difference. You know it fairly well with decimal system how it works. It is powers of 10. Here it is powers of 2. As I said, well, 1, 2, 4, 8. These are the powers of 2. So we place value. So first number will be times 2, second times 1, the second will be times 2, the third will be times 4, means 2 to the power of 0, which is 1, 2 to the power of 1, which is 2, 2 to the power of 2, which is 4. Likewise, it can go. And your computers, even if you take a very, very simple computer these days, it has got 16 digits, so you can see how many numbers it can handle. We are not talking about big microprocessors, okay, stronger ones, okay, simple, rudimentary, okay, great. So, as I gave you an example, a number 101 in binary, it has got only zeros and 1. The beauty is that these are at different places. So, 101, the number can be expanded, and just as you write expanded form in decimal number system, exactly same concept is used in the binary number system. Well, you could have many other number systems also. Think about it, right? You could create a number system with six numbers, right? Or 10. Instead of 10, we can have 7, 8, 9, whatever, right? So it's up to you. Well, zeros and word work most efficiently. So, as an example, once again, we have 101 here. So the one which is, see the place values are, these are the place values, correct? So 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, right? Add them up and you get 5, just as we did slightly earlier, right? Similarly, a base 10, 325, 300 means times 10 to the power of 2, 2 times 10 to the power of 1, 5 times 10 to the power of 0. That gives you 1, right? And you get your number 325. So, in binary, Think of it like light switch. It's like either on or off. Perfect. Makes sense. Now, in real world, as you can see, every file you use, videos, text, images, is in binary format, right? Artificial intelligence, data processing, and AI models is based on binary operations. Networking and cryptography. Secure communication relies on binary encryption. Digital electronics, microprocessors, logic circuits use binary gates. We'll learn about all these in this series. I hope you enjoyed this introduction to binary numbers and binary systems, right? And how useful they are. You are well aware of it. The only thing is, we know how to get into details, right? And understand them better, as in coming times, we need to work with them more than decimal systems. Great. So, here is a question for you as an exercise. We have given you a number which is 1011. It is to the base 2. So when we write in bracket, it means base 2, right? So, and I've shown you with my model of lights, right? So green one is 1, the red one is 0, the other two greens are also ones. You need to write this in decimal form. So put this in comments and answers. Also share with us about your views about this video and what will you really like to learn about binary numbers. What are the operations and how you can have fun with binary numbers. Share your thoughts. Thanks a lot for your time. All the best.